I'm Don Toporowski, and I'm the CEO of ReThink Mining, and this is the ReThink Mining Podcast. And today on the podcast, I have Mark Swinnerton, CEO and founder of Green Gravity. Welcome to the podcast, Mark.
Thanks, Don. It's a real pleasure to be here today.
I've got to say, I've worked in innovation a long time. Met a lot of entrepreneurs, a lot of ideas, seen a lot of technologies. And you and your organization stood out to me. I don't want to flatter you too much, but in terms of your experience in mining, the team you assembled, the technology, the way that you can express it, I felt really good about it. And I've only seen a few of those since I started getting into innovation and mining. So I thought I wanted to bring you to on the podcast and let some of our members hear the story of Green Gravity and what you're trying to do, because I think it's a really good one. But I also think it just stands out in terms of credibility. And I expect your company to succeed. Whether it's with the members of ReThink Mining or not, I don't know. But it's good to have you here.
Thanks. And I hope it is with some members of ReThink Mining as well, because you've got many esteemed members and the technology is so applicable globally, I think. And so I have high hopes that ReThink Mining is an important part of our future.
So some of the things that might disturb our members is that you left a perfectly good job at the biggest mining company in the world to start this thing. What was it about I guess you should tell us what Green Gravity is, and then tell us what made you think the opportunity for it was right now.
Look, thanks, Don. And in really simple terms, what is Green Gravity? Well, Green Gravity is a technology we've developed called gravitational energy storage, and it is all about helping renewable energy match the demand of the grid. And that means we need to store it sometimes when it's producing and release it later, to dispatch it later to the grid. And so we need energy storage assets. And our technology very specifically uses the gravitational effect of the Earth by lifting heavy objects up when we have excess energy and using that energy to increase the potential energy of the objects. And then when we need the energy released again, we lower those objects back down again through the gravitational field, and we're able to reproduce the electricity. And the really unique element of the way we do this is we take legacy mining assets, particularly mining shafts, and we use those as the source of vertical opportunity by lifting the objects up the mine shaft and then lowering back down again the mine shaft. So we're able to simultaneously produce an energy storage solution at scale to help renewable energy integrate, at the same time finding a new purpose and new use for legacy mining assets for which there are very few to none alternative uses. So we're kind of servicing two needs concurrently.
Yeah, I like that part of it, using the legacy mining assets, but how much renewable energy is hanging around a mine? Why do I need to store renewable energy at an old mine?
So these sites are heavily distributed, and the amount of energy that we can generate or store in one of these mine sites is proportional to mass times height. And so if you've got a very deep mine shaft, which many are, then you can get a lot of energy. And a big deep mine shaft in, say, Ontario in Canada could store 200 megawatt hours of energy. So really, really substantial in one mine shaft. And so when you've got conglomerations of dozens of them in concentrated areas, you're talking about gigawatt hour level storage assets, which rivals anything pumped hydro can do, but it has the added benefits of very small land footprints because we're vertical rather than horizontal technology. So we can take advantage of the depth, and as a result, we can be very efficient with land, reuse of assets, and connection to grid. And so that's a little story about the energy. Yeah.
So for people who are interested in energy storage, they probably they might have heard about hydrogen, compressed air, batteries, pumped hydro storage. Pumped hydro storage, by the way, has proven to be pretty good. Probably has 90% of stored energy capacity in the world, I think. And of course, batteries. Batteries I don't love because you're you're making a energy storage thing, and then you have these batteries to deal with. But they could surprise us by becoming solid state or using capacitors. But why do you think right now this idea of storing the potential energy in a mine shaft is better than all those? A lot of those are mature, some less so. But why do you think this is better?
Pumped hydro is very mature, and there aren't many other highly mature, long duration storage assets. So, as we add vast quantities of renewable energy, every marginal megawatt of renewables we add is going to need some further storage, and increasingly, it's going to need it at what we call different depths. So, it needs some short duration to take the volatility from this hour to the next hour. But it's increasingly, because of the reliance on the variable renewables, is going to need longer assets as well. So some that say, today I've got excess solar and tomorrow it's really cloudy. And so I need to store some from today all the way through to tomorrow. So you've got all of these different asset classes that are going to emerge. Each technology has a suitable applicability. Technologies that have a very low storage media cost, so that marginal additional length of storage is a low component of the capital, those technologies will suit the longer duration, which is coming down the pipe at us big time. There's actually, if you listen to McKinsey, there's $2 trillion of expenditure required on assets just at the long duration end over the next 20 plus years. And so technologies that favor kind of a more balance. So, your inverter and electrical costs are similar to your cell costs, for example, in a chemical system, they suit shorter durations. And so what you've got is different technologies suiting different parts of the market. And our technology suits the long duration, as does pumped hydro, but relatively few others. Hydrogen might, but it's certainly got some cost challenges. And then there's some others that are sitting out there, some thermal technologies. But gravitational technology is cost efficient, it's energy efficient, it's ecologically efficient, and it's really well suited to where the market's going, which is those longer durations. So we're going to see heaps of these technologies come in. We're going to see heaps of chemical systems like the lithium and solid state and sodium batteries and everything else. But the question is, where will they fit in the market? Because the market's vast and growing fast. And so I feel like we've got a great part to play in that. And then we'll be largely in long duration. We're going to be competitive in many markets. And I feel like we're going to be able to get a really strong piece of market share as a result.
So I believe you could use the mine shaft to raise and lower weights and store energy. But in order to store energy, I still need a source of energy worth storing, which means it has to be renewable. Solar or wind, I guess. And when I was thinking about a mine site, that it's kind of an industrial operation in a community. People have accepted it. It's provided jobs for all kinds of people. Now it's closed. If you said to them, would you rather try to naturalize this, or would you rather me put a gigantic field of solar panels, generate electricity, and employ a whole bunch of you? I have a feeling these communities might be in favor of building a giant solar farm. Is that the case, or is that just hopeful thinking?
Well, our experience has been that has been the case. And so we're working in multiple communities. And in fact, we've just announced last week a memorandum of understanding with the city of Wollongong. And that's been very, very well received in the public. And so we signed up with the city council last week to advance our technology in the city of Wollongong. And that brings with it the potential for jobs, investment, and reuse of relevant assets. And there's 40 legacy mines in Wollongong. We've also got a similar arrangement with the city of Mount Isa. And we're working in other jurisdictions like central Romania with the cities in the Dew Valley for just what you're saying. And the response that we get from these community engagements has been very much supportive of reindustrialization of the assets and the jobs that come along with that and the economic activity. And whether that's repurposing the shafts for storage, which, as you say, quite right, we're a storage asset, which means we still need a generation asset that pairs with us one way or another. But the potential to generate the solar or wind on the mine sites themselves, it seems to be quite a favourable topic when we raise that.
So what potential does it have for employment compared to, say, the number of people that a mine would have employed when it was active? Is it a significant number of people?
For a period of time, it is. And so I think we've got to break it into different job categories. And, one of those is the manufacturing of components for this technology, which is a really hardcore, good quality jobs in producing the components and preparing those. The second is in the construction of the technology, where we've got civils, we're installing head frames, we're putting in motors, etc. And then finally, there's the ongoing operations and maintenance, importantly, of the kind of gear, like mine winders, which we're using, need maintenance, and so we need high-end maintenance. But then we also have R&D, engineering, coding, AI. We've got a whole series of really high-end technical jobs as well that are required to advance the technology on an ongoing basis as well. So there's this great, interesting profile of jobs. If we look to a mining area and take in the area of Mount Isa, for example, so this is in central Queensland, Australia, 100 years of mining in the area, deep copper mining, and the mine in the centre of Mount Isa has announced closure and, in fact, proceeded to closure this year. That mine was employing 1,200 people at site. We have suggested in our feasibility work that we're managing through, and we're very public with the community and the other stakeholders in the region, that we could produce up to 350 jobs in that region for 10 years as we deploy the technology in, with a trailing jobs of maybe 100. And that's a little bit in generating assets that we'd add, a little bit in the storage installation, because so that's the kind of profile. So it's not the same as the mining, but it's still very high quality jobs for a pretty decent amount of time.
So I imagine there would be some people in the mine closure function who are really interested in talking to you. Seems like it has a lot of benefits, creates a lot of options that they might not have been aware of. But why do you need the mining company at all? It's an energy business, isn't it? You pay a fortune to build a gigantic generating operation, and then you have I presume it's quite a bit of capital to build this machine to store it. The only thing the miners are doing is providing you the shaft, which they probably would be just as happy. I don't know. Are they just as happy to say, close it and forget about it? I'm done with it. Like, I don't understand how the mining company fits in. And what do they get out of it for giving you 10 minutes of their time?
Well, it's an excellent question. And there are various stakeholders in any region around the potential to deploy this technology that are able to gain and really play into this. So one is absolutely that it's an energy play, and it's an energy infrastructure play, and we need to set up a company and fund that and get an off-taker for the energy. And so that's one lens on this, and that's quite right. But the second lens I want to bring in is that of the mining company. So in many jurisdictions, what we find is, of course, the mining company has other operations in an area. They have obligations to remediate and ultimately relinquish the assets. They have a stewardship with their stakeholders, the community, the government, the First Nations and others that they want to look after. That's the conversation we have very regularly with our mining partners, and we're working with 45 mining companies globally right at the moment in various levels of conversations. And what the miner is able to bring to the party here is really multifaceted. They're able to bring the legacy asset, of course, but they're also able to rally the stakeholders in a way that their ongoing remediation needs can be optimized. We can generate more revenue from the asset. We can therefore bring forward more remediation, but we can bring forward jobs in their community. We can give them energy and carbon benefits to other operations they may have in the area. It helps with the potential permitting of new activities, because you've got a full life cycle of activity going on, where the miner is stewarding the asset all the way through to a future use, which means that they're more likely to be seen in a positive light when they want to bring on new mining assets. And so we're seeing that absolutely already. And good example here is in the New South Wales jurisdiction of Australia, where the government recently brought down an inquiry. Well, actually, the Parliament brought down an inquiry and the government's accepted it, called the Future it's called post-mining land use inquiry. And that inquiry is all about what do we do with these mining assets at end of life? How do we handle the liabilities that are there and need to be discharged? And the inquiry is very favourable on repurposing to renewable energy and the kinds of technology. And we got a lot of mention in that inquiry. And it's something that shows that the community and the government want to find ways to permit new sites, but with full life cycle understanding. And that's where I think the miner can get a lot of benefit in working with us.
The other thing I'm thinking about is a lot of these miners are trying to transition to the electric mine, and they don't have the power. It's just not available, too expensive to get it there. It's impossible. So this would be one way, I guess, a generation asset could be created, and it could be stored in a nearby mine shaft or closed mine and be available for other mines to use. Is that basically, are you expecting to bring the energy to mining or to some, there's not much else in those remote communities, is there?
Well, that I'd like to challenge that paradigm. And so where there are remote mining community, yes, it may be that the mining activity is the dominant consumer of energy and maybe a very much increasing user of energy due to electrification of the mining fleets and mining activity. So that's quite right. And in that context, our technology is an absolute game changer. And the reason, Don, is that the cost of solar energy has plummeted. It halved in the last few years. It is easily the most cost-effective, efficient form of new energy generation. But it's got a huge drawback, which is it only produces when it's sunny. And so at night, we produce no solar at night. And so as a result, our technology, which can use the legacy mining assets in the area to turn solar into baseload, that is a game changer for electrification in those circumstances. But I want to challenge the paradigm that is the dominant circumstance. And I'll use Sudbury as a good example for your listeners in Canada. Sudbury is by no means remote. It's grid connected with 500 megawatts of grid connection into the main grids. It's central to between generation in the north and consumption in the south and Ontario. And so what you have is this really interesting example where you've got hundreds of mining assets in the Sudbury area that are potentially suitable for this technology and a massive potential public good from being able to firm variable renewables from the north and optimize your transmission into the south. And this can save billions of dollars for the Ontario taxpayer through improving what's called transmission augmentation and transmission investment deferrals. There's one use for the technology to take those kinds of assets and make them really pay back for the grid and for stabilizing the future variables. Because while Ontario today has lots of nuclear and lots of hydro, it also uses a lot of gas. And as you massively increase energy demand, which is, if your Ontario government says you're going to double electricity demand in the next sort of 20, 25 years because of data centers and because of economic growth and population growth, that's going to come from only one place, which is wind and solar. It's very hard to scale up nuclear and scale up hydro. It's going to be a lot more wind and solar, so a lot more variability. So there's a second paradigm, and we see that in a lot of places where there's these on-grid, near-grid applications that are just beyond the mining fleet. They can really play into the overall energy dynamic.
Is there a shortage, if you look at the current renewable energy generation capacity and you look at the storage capacity, is there a mismatch there, or is it going to be a growing problem where more storage just has to be created somehow?
The latter. So what you find is that at low penetrations of wind and solar in a grid, the grid kind of can buffer it. Like, your carbon assets or other assets just kind of mask the variability that's going on up to a point when they can't. And when they can't, you must start layering more and more storage assets. Or what you get is just fluctuations in price on the wholesale market that just grow and grow and grow. And you start to see shortages or surpluses that become more difficult to manage. You also see grid quality issues. So you see issues with voltage and frequency that can be hard to manage and other grid factors. So what you're going to see is an ongoing progressive need for asset build out, that as you build a renewable asset, you're going to need to pair it with a storage asset. And we're seeing some advanced markets where, like, you go to California, almost every utility scale renewable asset is firmed behind the meter, where they put batteries in with it. And you're going to see those kind of things happening, but you're going to see it on a much broader base. And so you're going to see not just okay, I've got some solar that's at lunchtime and it needs to be used at dinner time. You're going to see, I've now got a huge proportion of my generation coming from variable sources, and I need to store it for next month or next season or next week. Those kind of challenges will just start to emerge and are emerging in different markets now. I mean, I'll give you an example. In Australia, we had a few months ago, we had an unusual dip in the wind, and it went for several months, 2 months, 6 or 7 weeks of just abnormally low wind flow. As a result, wind generation dropped, and what we saw was a need to step in with more gas generation to plug the hole. And we depleted a substantial share of the winter gas reserves from the storage facilities because we had to step in with excess gas generation in the electricity grid. There's an example of all these consequences. We need to find and have more storage assets as resilience in the grid to take additional generation and have it available for when things like a wind strike happens for 6 weeks. That's just going to happen, and we've just got to manage it.
So I understand you're making progress in Australia, but when you came to Canada and we were talking about the potential of the Sudbury region to use this kind of technology, I liked it for all the reasons you were describing. Taking that one specifically, I'm sure there's a million different models. But who would pay for something like that, the generation and the storage asset? And how would the miners in Sudbury fit into that whole thing?
Well, let me give you 2 example case studies of who might pay. The first might be an incoming data center who's providing services to ChatGPT for kids in Sudbury, for example. And that data center, very power hungry, it's going to build in its new demand to the grid. And that's going to have to be decarbonized. No one's going to tolerate the data center sector ballooning up these huge assets and doing it all by creating more emissions. I can't see society accepting that as the way forward. So we're going to see more renewable assets added to service that data center. And as a result, they're going to want uptime because guess what? We use ChatGPT at night as much as we use it in the day. So as a result, we're going to need firming assets in the region for that data center. And the mine shaft can be the firming asset to support that all-night operations of the renewables for the data center. So as a result, there's one example of a buyer for the product. The miner's role might be they've got a spare mine shaft in their asset that's no longer being used, or it might be a ventilation shaft that needs very little activity as ventilation, and we're able to fit our technology to that shaft and play into the energy generation element. There's one example of a buyer. Another example of a buyer might be the state grid that is looking to invest more money in transmission assets that are very expensive and very long dated. And they may be willing, as they are in many jurisdictions and do in lots of locations, including Canada, they will write a contract, an offtake contract to a storage asset to help defer capital in their transmission investments. And as a result, they'll create an offtake agreement for the storage asset that is able to be bankable and enables the investment to happen. So there's a second example again. And I said Sudbury's in a wonderful location for grid augmentation, as many other mining assets are within Canada and around the world.
So this past month, I've been spending a lot of time talking to mine closure people. They're a very frustrated group. You know, innovation people are frustrated because they generally have very little budget. No one wants to try anything new. But mine closure people are even more frustrated. And it's almost like the miners say, sure, I want to be a good citizen. Sure, I want to take care of the community. But really, I'm in the business of making money. I need to spend as little as possible to take care of this and be good at the same time. Is there a way that them participating in energy storage project could make them money?
This is a game changer for the mine closure community. For all of your listeners that are a mine closure practitioner, well done on staying the course and doing great work. We are part of a solution that you ultimately take back to your organization and say, okay, you were looking, the organization's paradigm is to look at closure as a very, it's a cost intensive, long dated, risky exercise. And so it's, as you say, it's challenged in attracting capital and so forth. They can turn the conversation to say, well, please, when this asset's closing, we have a way to lease the asset to Green Gravity, to get an energy play in, to generate new energy options, carbon options, employment options for the local community, a totally different dialogue around closure, and change the way that new permitting for other assets might happen, and at the same time, still discharge the closure obligations that the miner has. Just do it in a different way and over a different time frame, but a different time frame because they've been able to add a lot of value in the intervening period. So this is a game changer to flip the tables on the way we think about closure. And that's one of the reasons I think it's very exciting. There's thousands of assets out there that are facing the same pressure from the boss, which is, hey, this is a cost, net present cost. This is a way to make that net present cost lower. And that, therefore, the net outcome is it's worth more.
So they could make a deal where they lease the mine shaft, basically. Maybe it's there's all kinds of different models, but basically get paid for leasing the mine shaft. And with that money, they could actually do a lot of good in the community, I guess, too, right? Related to the closure.
Absolutely. So it becomes a partnership kind of exercise. They lease it. There's a financial outcome that's there. But the bigger impact is they're then part of a new repurposing activity that means that they've created a lot of good for any of their stakeholders that are there, and that gives back in lots of other ways, and miners get that. And so it just creates a totally different dialogue for them around how to think about closure.
You're going to make a lot of mine closure people happy, I think. If it gets going and if it's succeeded, because they're really unhappy right now. In fact, they just dismantled a group that was getting together, ICMM, I think. They dismantled that group on mine closure. And so now all those people are fragmented, working in smaller little groups together to try to solve problems. This would be a good one that would interest them.
Yeah, but if you look at economic theory, Don, I mean, we talk about land, energy, and labour. Well, the legacy mine has land. We're bringing the energy to it in a totally different way because we can firm the renewables overnight. So this is the game changer, that it now becomes competing with any energy asset and economically so. And then we talk about labour. Well, many communities where the mining industry is in decline or there's a lot of closure going on is long labour, quality labour, because the workforce has been shrinking. So we've got all three components of massive economic activity actually sitting in a concentrated area. And that's a big secret. So we talk about the direct implication that we can have to a mining asset or to a region in those three dimensions. But there's also this dimension of, well, what else will come in on top of that? If you've got excess clean, firmed, renewable energy, excess labour and excess land, the mind boggles as to what new industries will be attracted to these regions. And I think that's a story and a discussion that needs to be had.
I really like it. So then when we met for the first time, I challenged you on the technical validity of it. And I was surprised, first of all, by the scale of your operation, the money that's gone into it, the quality of the individuals working on it, the size of the team, and the progress you made. It was kind of shocking because you've been under the radar for like 3 years. Maybe you were operating, working outside of mining, working with energy people more, but I hadn't heard of you. And when I started challenging the technology technically, I kind of believed you. So let's just go through some of the things.
Yeah.
Electric hydro storage is pretty simple. You pump water with pumps. It's well-known stuff. Go from one reservoir to the next. I don't like the ones, by the way, that want to store water in mines because there's too many challenges with that environmentally. But if you were to say, what's the next simplest thing compared to pumping water? It's probably raising a weight up and down. And so you got a cable and you got a weight. And when I first encountered it, I'm like, okay, it's going to be like some iron weights. And I was imagining, I don't know, like a cuckoo clock or something. And then when you described the scale of the thing, Like the size of these weights and the amount of weight and the distance it's going, I'm like, oh my God, that is a massive energy storage thing. So let's just talk about that. You got, I guess a good shaft is probably 300 meters deep. More than that probably makes the thing economically much nicer. But so let's take a shaft 200 or 300 meters deep. I don't know, how wide a diameter are we looking at that?
Well, why don't I use a 500 meter? Because in our suburb where I live, we've got 40 500-meter shafts. So that, you know, we do quite a lot of work with that, and we're working with ones deeper than that, of course, as well. But let's take 500 meters, and the average diameter of those shafts that we have here is around about 5.5 meters diameter, in the circular sunk shafts.
So what are you lowering down that 5-meter hole?
What we're lowering is discrete packages of mass. We call them weighted objects, and these are designed to tackle some quite interesting engineering challenges for the engineers listening to the podcast. They'll really love the kind of disciplines we need to bring to the production of the weighted objects. And these we have an objective to get them as dense as we possibly can, because we are space constrained. We have a certain volume within the shaft, and our energy is very, very predictable. We know that it's equal to mass times height, is how you calculate how much energy we get. And actually, what we learned early in the tech is that by moving one giant mass, which is the simplest methods, you start with as simple as you can. I'm going to move one whopping big weight. What we find is that there's constraints to how big you could make that weight ultimately. And if you then do the maths, you just can't get enough mass to pay for the capital of the system. So it doesn't work only moving one weight. So what we arrived at is we have to move lots of weights. So let's get about designing a system that can take packages of weight that are of the sensible size, that optimizes the capital and the operating costs of doing it. And what we do is we say, well, we want to get as many of those weights in as we can. So let's get them as dense as we can, firstly. Secondly, we have to have them, we have to move them at pace. So because our power is equal to mass times velocity. And so we now need to be able to move them. So as you move a really big, heavy thing at pace, it goes into tension. And so we need to have something that is able to handle tension. And then ultimately, we're able to put weights on top of each other, which means we put them into compression later. So we have to have something that's dense, low cost, can handle tension, can handle compression, and is highly durable. And has certain surface qualities, and we're able to grip it effectively and everything else, because we've got to move it around, release it, move another one. And so we're moving, hundreds of these masses reliably all the time. And so there's quite a lot of technology in getting those things right. And they're very big. Like they're, as you say, like we can take a shaft and produce an object that's 5 meters diameter and, maybe a meter high, and grip it and move it at pace. So that's where the technology development's been focused.
So when you get it to the bottom, you can't move it aside. You just stack the other ones on top, I guess.
Correct. We have a beautiful design feature, Don, where we don't put anyone in the shaft. This is important for your mining related stakeholders and your safety and government, other listeners to this podcast. We're all about saying, let's not put someone down the shaft. So we don't want to have to put someone in harm's way or worry too much about the condition of the shaft. What we want to be able to do is repurpose it in a way that it's fully autonomous. So yeah, we're not moving things. We don't have anything fancy down the bottom. We've got a variety of important techniques, but ultimately we stack those weights at the bottom.
If you had a 500-meter shaft, how high do you think you would stack this stack of weights?
Ooh, we can stack it to hundreds of meters.
Really?
And so there's technology in that as well, actually.
I guess you've never played Jenga, eh? What prevents this thing from toppling over?
There's a variety of techniques in how we produce the masses, how we place them, how we monitor them, and how we guide our weights in, that means that we're able to create a very stable structure.
And for these weights, I guess you've got to have a lot of cement in that. Are you going to use waste material from the mine, or what are you going to make them out of?
Yeah. So we've got so one of the other KPIs that we had on that was to also have very low embedded carbon in the technology. There's no point in us producing a piece of technology that uses more carbon to make it than it saves in the energy product at the end. So we are very focused on making sure we get extremely low carbon. We're working with universities in Australia. We've got a wonderful relationship with multiple universities. One of them we focus in specifically on the materials selection and optimization for the weighted objects, and that includes very low carbon concrete as one component of the blend. We use some waste products, and we use some other strengthening and densification techniques to bring, I think, really smart materials thinking to how we produce these weight objects at scale. And we intend to manufacture them in region. So where we are moving into a mining region to deploy the technology, we will move manufacturing into that region to then produce really large quantities of these weights that will be required.
If I'm at a closed mine, I have a bunch of buildings and steel lying around. Can I throw all that into the weights?
Yes, within reason, we need a certain level of processing of it. And but absolutely, the intention is to enable that circular economy very locally, and that makes economic sense as well. By the way, because there's a lot of logistics and carbon cost of moving those waste products away from the site and going somewhere else. So this enables a circular economic thinking at site.
To take an idea like this, get it to where you got it, to start building these facilities, the energy generation combined with the storage, get the approval of miners, community, government, regulators. This is a huge job, and congratulations for making the progress you had. I actually think you're going to succeed. And I think you might succeed in Ontario, in Sudbury, where a lot of our members are very interested. And I know you're making progress in Australia, but if you were to or if you were to send a message to the 20 global miners who are members of ReThink Mining about how they could help advance this technology or participate in helping to make a success, what would you ask from them? How could they help you?
Well, thank you, Don, and appreciate the vote of support as well. And we'd ask for one simple thing. This technology, as you say, we're making excellent strides in Australia, and we will be commercial soon in Australia. In fact, we've recently announced our final major production demonstrations will take place in Australia, and we're going to be welcoming guests from around the world, including in Ontario, to come visit facilities in Australia during 2026. But we're also open for business right now in Ontario to start to find a way to do the market development work to localise the technology for Ontario. And that includes, we need to work towards finding a suitable demonstration mine shaft, likely in Sudbury, that can accommodate and localise the technology and prove it for the local conditions, including the temperature conditions, including the regulatory conditions, and the market conditions. And so we're open for business to find that right site, to engage the local closure and operations groups and energy groups, but particularly closure and operations groups for mining companies in Canada, and particularly in Ontario as our first step, to talk about what it could mean for their planning, and to start to seed the ideas that there's alternative cases for their closure plans, and that there's alternative business plans for their assets that we can play into. And then secondly, we want to work with the regulators in Ontario to begin to explain the technology to them and to show the pathway for how the regulatory treatment could work to get an even better outcome out of the post-mining land use options that sit there today in Ontario.
Can you imagine a project where it would be beneficial for miners to work together on it? Take Ontario again as an example. Why have more than one miner? How would that make the thing better?
There's absolutely a case for more than one miner to be participating in this. And here's the reasons. Firstly, all of the major miners have legacy asset portfolios. They all have impending legacy assets coming down the pipeline at them. And so they have the same challenge. And these assets are not core business for any one of those miners. Their core business is in mining and in extracting resources efficiently and safely and with environmental credentials and getting that to market. These assets are different. And so accordingly, these are non-core. They all have them. And what we offer is a new thinking around how you might consolidate those and get scale efficiency, how we might repurpose for much superior use than what's currently being considered for those assets. And we can do that in a way that the more scale we can bring to that, the faster we can move and the more benefit we can generate. So I see there's a strong case for collaboration. And there's no competitive dimension between the miners today on this one. This is not an anti-competition issue. These are legacy assets. And so I feel like there's a strong case for a conversation around how an industry-wide or a multilateral process could work in Ontario and in Canada.
Yeah, I agree with you. And I really want to make those mine closure people happy. They've been trying to introduce technologies to mine closure and they're getting nowhere. I think this one, has a really good chance of making a difference.
And I think the reason for that, the reason this is different, is that most technologies are developed for a purpose and may be adapted to the legacy mining asset. This is the opposite. This is designed to inherently use the asset itself. We can't exist without that asset. So it's utterly central to how this technology works. That's the difference. This is built for it. This isn't about trying to make it fit and a square and a round. This is designed for it. So I think this is why it's a complete game changer.
All right, ladies and gentlemen, that was Mark Swinnerton, CEO and founder of Green Gravity. And I'm hoping we can get a consortium together on this to support this company, Green Gravity. And if you're interested, you can get in touch with us at ReThink Mining or with Mark himself. And thanks for telling us all about this today, Mark. I love the technology. I love what you're doing.
Thanks, Don. And we're a huge fan of ReThink Mining, and we're wishing you every success, and we're hoping to do more together in the near term.
Very good. Thank you.